Hey everyone, so my name is Thiago. I'm going to present what me and Penguin have been working on. We've been working on real-time face recognition. So actually when we talk about that, we want to talk about two different and separate problems. We want to talk about face detection and then face recognition. So for the first problem, what we're going to solve is, given an image, are there any faces on it? And if their answer is yes, where are they on the image? And once we actually have just the face of someone, I mean, who is this guy? Who is this girl? Do we actually know them? Do we actually have enough information to to differentiate them from someone else? And then we come to this problem of how hard it is. So we have to be able to deal with different poses. So you want to maybe you have like someone looking forward to the camera and then someone looking to the side. We might have different lighting, and then someone in the background can be smaller than someone who's in the foreground, so we have to deal with the scale problem as well. And also color, maybe the color will differentiate how we detect or not faces. And then when it comes to face recognition, we know that each face is unique, but they can be very, very similar, as you can see on that image at the bottom. So we want to gather information maybe about the eyes, nose, ears, some measurements on the faces that we are able to distinguish the different persons. Maybe we have to deal with subjective characteristics that we don't even know what they are, but they might be meaningful to solve the problem. So first what we want to do is actually identify some faces on the image, as I said, and then extract unique features from each person that will be able to uniquely identify them. And then we want to classify them correctly using a traditional classification algorithm. So we're going to take a look at the first part now. So what we did is use hog features, histogram of oriented gradients. So as we've seen in class, what this does is for each pixel, we compute a gradient of all the surrounding pixels, so we know where the image is getting darker or brighter. But once we get all this information from every single pixel, we don't actually gather a complete overview of the image. We're actually only looking at this every single pixel. So what we want to do is get a 16 by 16 square on our implementation, so we can have something on the top right of the slide, which is a better representation of the whole image. This will give us more relevant information, and maybe you will remove a little bit of noise. So in this way, we introduce robustness to lighting. So it doesn't matter if you have like a bright image or a darker image, as long as the gradient is the same, we're able to distinguish. And this is color invariant as well, since we use a grayscale image, so we are computing the gradient using grayscale. And also the same way as the lighting, the scale of the image doesn't really matter as long as the gradients are the same. So what we want to do is, once we get a bunch of images, we want to get something like this in the middle. We want to get a face pattern that once we have the hog version of our image, so once we have applied the hog feature extraction on this image, and then once we have like this general pattern, once we compare those, we are able to identify and localize the face inside an image. So secondly, we're going to extract unique features to identify each person separately. So on a typical deep learning approach, what we would do is, after the training, we would have a test image, we would extract features from it, and then with the trained weights on a dense layer, we would just give an output, let's say a cat, we are giving a final prediction. But what we want to do now is something a little bit different, which is called deep metric learning. And what we do is use what's called a triplet training. So we have two images of the same person as an input, and also another third image of someone different to the algorithm. So what we want to do is project these images on a different representation space. So the two images of the same person stay closer to each other, and the third image of the second person becomes separate, becomes further away from those two. And this is done just as we know we're giving small weight adjustments throughout the training. so we can actually represent them on different parts of this space. So we used a modified version of the ResNet 34 with a fewer layers and small number of filters. So this model was pre-trained on about 3 million images. And it was tested on this labeled faces in the wild dataset. So what we can see here is a couple of matched pairs. So we want to give, say, these two images of one guy and then one image of this guy here, so we can differentiate them. Next, so finally what we want to do with this is either using Hog, as I mentioned previously, we want to either encode someone's face into 128 representations, either using CNN or Hog. What we want to do is just extract features for someone's face so we can actually uniquely identify them. So next, finally, we want to classify them correctly. So once we have this higher dimension representation of someone's face, we want to separate them, in this case using linear SVM. So instead of having like a line or a plane separating a 2D or 3D problem, since we're having 128 dimensions on this problem, we want to find like a hyperplane that is going to be able to separate this higher dimension space. It's a powerful and versatile method that was suitable for our data set. And then here we have our simplified pipeline. So once we have an image from a webcam or from your hard drive or something, we can first detect the image and its location, and then once we have just the face, we want to encode that into one representation and then compare it through a simple distance metric to what we already know. So we have like a bunch of people that we know. We have this new guy. Who is this guy? How close it is from one person or another. Yes, that's pretty much it. So here is our data set preparation. So as you can see, we have a few images from the internet, a few actors and actresses, and also friends and family and myself. And yeah, we're going to show a few results. So this was one image. As soon as we have encoded all of the spaces that we saw on the previous slide, once we have an input image, we're able to identify, detect and recognize each person individually. We also have like a live webcam feed that I have recorded with my flatmate. I'm going to show you later how it was before I encoded his face and how the algorithm was not able to identify it before I encoded it. And also, if we have a video file of this interview, we have Robert Downey Jr. on the left, Chris Evans and Jimmy Kimmel. And that's pretty much it.
Great.
Do you have any questions?